Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with the chapter Integration. What did we learn? We started with the basics of integration formulas, then we did a few problems based on that, and we also learned the substitution method, right? Fine. Today we are going to learn a new and the innovative topic, that is integration by parts. What is this? As we discussed, we know that whatever the topic we learn in the integration, it is always analogous to our differentiation topic. It is completely opposite of that, right? Or else simply it is called as antiderivative of a function. Yes, fine. What are the different operations we learned in differentiation? That is not just two functions. Let me tell it simply. If there are two functions which are separated by a addition function, then we differentiate them separately. If they are in the subtracting way, again we differentiate it separately. Yeah, right. For example, if there are two functions f plus g, if I want to differentiate these, just I will differentiate f first and g first, right. Even if they are in a subtracting notion also, we will do the same thing. What if they are in the product form? We used to have a uv form, right, that is uv dash plus vu dash. Even if it is in the division form, we used to have a formula. Fine. Similarly, if it is in the integration, we can just integrate them separately, right. Then what about the product form? That is, we can do it by parts. How do we separate into parts? We will have only one popular formula, that is, if it is uv dx, then I can write the formula as u into integral v dx minus integral du by dx into v dx whole dx. This is the popular formula we have to remember from this exercise. Clear? Once again, see here, integral uv dx can be written as u integral v dx minus integral du by dx into integral v dx, again whole dx. Okay, we have multiple integrals in this term. Clear? This particular term has many advantages and disadvantages. Okay. Let me give you an example. For example, if there is an e power x function, if v is e power x, then I can write it as integral e power x, again integral e power x, again it will be e power x. Clear? That will be a kind of infinite loop. So we can have that kind of default things also in this form. Clear? Is it okay? Fine. Not only remembering this formula, but there is some logic to apply this formula, that is isolate. Okay, this particular term is very important. Okay, what is this isolate is? Here the order of functions which we apply here, u into v. For example, if I say a power x into e power x, if I want to differentiate it, just I will take this as u and this as v, or else we can take this as u and this as v. But while doing integration, we can't take whatever we want. We have to follow this isolate ka rule. Okay, that is, we have to go in this order. What is this isolate? I indicates the inverse functions. Okay, that is, it might be inverse trigonometric functions or inverse trigonometric hyperbolic functions, right. So that can be. L is logarithmic. Okay, log of something or ln of something. Clear? Next, A is algebraic, T is trigonometric, that is, it can be sin or sin h. Okay, at final E is exponential. Okay, what is the difference between algebraic and exponential? Algebraic is variable power constant, exponential is constant power variable. Just to know this difference. Trigonometry is whenever we have the functions such as sine, cos, those all, and logarithmics inside log something. Next, inverse is some inverse function, sine inverse or cos inverse or hyperbolic inverse functions. Clear? Did you understand? First, you have to check which is u and which is v and directly applying this formula. Is it okay? So, now you can understand this a power x and a power x formulas are difficult to integrate. So we need to have some direct formulas or reduction formulas for that. Reduction is after going to some extent it has to stop. We don't know where to stop. So we will have direct formulas. In order to do that, first formula we will learn about this e power x is integral e power x into f of x plus f dash of x dx can be written as e power x f of x plus c. Clear? This is one of the simple formula to remember. Clear? Shall we start doing the problems on integration by parts? See here. The first question here it is integral x secant square x dx. So which is the first term we have to take? First thing, check whether you have two terms or not. Yes, we have x into secant square x. Right? Yes or no? So check, isolate. X is algebraic form, secant square is t, trigonometric. So which is first? However algebraic is first, so we will take the first term as x. So here u is x, v is secant square x. Is it clear? Is it fine? So let us write the formula. What is the formula? Integral u v dx is integral u integral v dx minus integral du by dx into integral v dx whole dx. Clear? So shall we substitute? See here. Now integral x secant square x dx is u is x integral secant square x dx minus integral differentiation of x integral of secant square x dx whole dx. Is it clear? You can understand this particular term, right? So now let us directly simplify. X integral secant square x is tan x. Again integral of dx x square by 2. Integral of secant square x is again tan x dx. Sorry, differentiation of x is 1, right? So 1 tan x dx. So x tan x minus integral 1 into tan x is again tan x. What is integral tan x? That is nothing but log secant x plus c. Clear? Is it okay? What did I do? Just we will take the first term as u and second term as v and directly applying the formula, so that we will get a answer. Is it okay? What all we learned? Just we learned this formula and this particular direct formula. This is very important for 2 marks. This is also important. How important is? We can't do next all the problems without this formula. Clear? Shall we start doing the actual formulas of this integration by parts? Let's do. Look at the next question here. He is asking us to find integration of log x. Just tell me, do we have a formula for integration of log x? No, right? We had differentiation of log x and 1 by x ka integration is log x. So how do we find the log x? We can find the integration of log x by integration by parts method. That is, let me say f of x as 1 into log x. Can I write? Yes. So 1 into log x, however it is log x. So we will take one term as 1 and one more term as log x. Okay, fine. So log x, it comes under L, logarithmic. Yes, you have to remember, we have to write the functions in the order of isolate. So logarithm comes under L. What about 1? We always consider 1 as an algebraic term. So we will write integral log x dx as integral log x into 1 dx. This will be u and this will be v. Why? When it comes to isolate, L is first, algebraic is next. Isn't it? Shall we substitute in the formula? You will directly get the answer. And with this formula we are going to use in next formulas. Integral u v dx is nothing but, let me write it clearly, u integral v dx minus integral du by dx integral v dx whole dx. So let us use this formula. That will be log x integral 1 dx minus integral differentiation of log x into integral 1 dx whole dx. Clear? Log x into integral 1 dx क्या होगा? Integral dx is nothing but x, right? Next, what is differentiation of log x? 1 by x. Yes. Next, integral of 1 dx, again x. Here if you observe x will get cancelled, then I will write it as x log x minus integral dx is x, right? Now just tell me what is the integration of log x? That is x log x minus x. You have to remember this formula, right? More than as an important question, we will always consider this as a formula, because again we have to use this formula in many places of our LAQs. Clear? Fine. Look at the next question. X sin square x ka integral. So what does this A is? I mean x is algebraic, sin square is trigonometric. So algebraic, this is x is algebraic and sin square is trigonometric. So according to our rule, ILATE, which is first? Algebraic is first, trigonometric is next. So we can directly take x as u, sin square as v. So let us directly substitute in this formula. See here, from now I will directly write the answer. U integral v dx minus integral differentiation of x 1 integral sin square x dx whole dx. Yes. Now tell me what is the integration of sin square x? Can you differentiate? No, right? Again we have to convert it into cos. So we know that 1 minus cos 2 theta is 2 sin square x. So sin square x can be written as 1 minus cos 2 theta by 2. 1 minus cos 2x by 2 minus integral, this is double integral, 1 minus cos 2x by 2 dx whole dx. Isn't it? So here by 2 will be common. Now integral of 1 is x. Integral of cos 2x is sin 2x by 2 minus integral, again 1 by 2 is common, 1 ka integral is x, cos 2x ka integral is sin 2x by 2, again whole dx. So let us simplify this. X square by 2 minus x by 4 sin 2x half x ka integral x square by 2 sin 2x ka integral minus cos 2x by 2 plus c. So let us multiply everything. X square by 2 x by 4 sin 2x minus 1 by 4 x square minus 2 to the 4, 4 to the 8 cos 2x plus c. Clear? If you want to simplify, you can simplify further, subtracting it you will get x square by 4 and so on. Is it okay? This is how we are going to solve integration by parts. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He gave integral of x square tan inverse x. So again which term has to be taken, u and v? Let us check. Now x square belongs to algebraic, tan inverse belong to inverse, right? So we can take it in the form of ILATE, so that I will be inverse, A will be algebraic. So which term will be our u? First term, that is inverse ka term, which is tan inverse will be our u, algebraic will be of v. So let us write uv ka formula. U integral v dx minus integral du by dx integral v dx whole dx. So let us write in the formula x square, sorry, what is u? Tan inverse x is u integral x square dx minus integral of differentiation of u. What is it? Differentiation of tan inverse x is 1 by 1 plus x square. So integral of v dx, x square ka integral is x cube by 3 dx. I am just increasing the speed, check it. Fine. So this will be tan inverse x, x square ka integral x cube by 3 minus here 1 by 3 x cube by 1 plus x square dx. Clear? So how do we solve this? X cube by 1 plus x square. If the numerator ka degree is less than denominator, we would have done something, that is f dash x by f of x, something like that. So how do we solve this? So let us take this separately and solve that. X cube by 1 plus x square ka integral. How do we solve? So let me take x cube as x into x square. Can I take? Next, let me take x separately. Let me add and subtract 1. Can I separate it? Yes. So now we will separate the denominator. X square plus 1 by x square plus 1 minus 1 by x square plus 1. Can I separate it like this? Yes, right. X square plus 1 by x square plus 1 minus 1 by x square plus 1. So these both will get cancelled. I will be left with x into 1 minus 1 by 1 plus x square. So I can write it as integral x minus x by 1 plus x square whole dx. Is it clear? So now tell me what is the integral of x? X ka integral is nothing but x square by 2. Either we don't have any integral, so let me multiply and divide by 2. Okay. After removing this 1 by 2, now tell me the integral of 2x by 1 plus x square. What is the differentiation by x square? 2x, right? So it will be half log 1 plus x square. Clear? So this is this answer. So I can write the answer as x cube by 3 tan inverse x minus 1 by 3 x square by 2 minus into minus plus 3 2s are 6 log 1 plus x square plus c. Clear? Is it okay? This is how I will solve all the problems of integration by parts. Clear? Is this okay? Fine. This is for today. Let us meet in the next session with the more problems of integration. Thank you.